So now let's look at some exam possible questions and past questions under quantity number and electronic configuration. So if you are a chemistry student and you be writing the upcoming JAM, then these are the type of questions you should be expecting in your upcoming JAM examination. Like, and it's under quantity number and writing electronic configuration. So this question, I'm going to use this question to explain the whole concept. But if you want to get the full videos, I will leave the link to those videos at the comment section. So that if you have not watched the full video, we are explaining step by step method on how to understand what is quantity number and write electronic configuration, you can go check out those videos. Just or you stay to the end where the link to the video will be there, right? Like the link to the video will be there, or you look at it at the comment section. If you cannot find any of them at the comment section or anywhere, just leave a comment section that you need the video on the complete video on quantity number and writing electronic configuration. But in general, most of the questions I'm going to teach in this video, you're going to see them when you're going to see them in the exam. Now you're going to see one or two of them in the exam, and you're still going to see them in your post-GME exam. So you want to stick to the end of this video here and take down every single thing. Let's get into it. So let's tell what the first question. So I'll be using it to explain it here. But let's look at what the first question here. The ion which is electronic isoelectronic with neon is. So they say that the ion which is isoelectronic with neon is. So now what does the word isoelectronic mean? Isoelectronic, when we talk about isoelectronic, what does it mean? It means that they have the same electronic configuration. They have the same electronic configuration. Now, how do they have the same electronic configuration? For two or more compounds to have the same electronic configuration, that they must have the same electron number. Just because when you're writing electronic configuration, you use the electron number. That's why it's called electronic configuration. So in exam, you have to say what is the electron number of neon. Neon, Ne is 10, right? Now remember is noble gases, so they don't lose or gain electron, right? At the base, they don't lose or gain electron. They are stable elements, just so they don't react at the beginner stage. But as we need to move on, we now find out this element they react under some conditions. So now the electron number of neon is 10. Just is 10. So if you want to write the electron configuration, you're going to be what? 1x2, 2x2, 2p6. Just that. So when I write the electron configuration, use the electron number. So once you identify the electron number of neon, then ask yourself which of these ions have the same electron number with neon. Just which of these have the same electron number towards neon. So let's look at what aluminium, right? Now aluminium, the atomic number, the neutral atom of neon, the electron number is 13. Just the electron number is 13. Also the proton number. Remember, in a neutral atom, the proton number is equal to electron number, right? So when atom lose or gain electron, they now become positive charge or negative charge. When elements lose electron, it becomes a positive charge. But when it gain, it becomes a negative charge. Just so this aluminium here, its natural state, the electron number is 13. Just but here we have Al3 plus. It means that it have lost 3 electrons. So whenever I see a plus, it means that I have lost electron. How many numbers of electrons did it lose? It's 3. Remember the neutral atom, aluminium is 13. Aluminium is 13. Aluminium is 13, right? Now when it lose electron, which is 3 here, 3 plus, it now become 10. So the electrical configuration of aluminium here, Al is 3 plus is 10. Just so if you want to write the electrical configuration, it's going to be 1x2, 2x2, 2p6, 10. So neon and aluminium have the same electrical configuration because they both have the same electrical configuration. They are called isoelectronic. They are called isoelectronic. So the word isoelectronic means that they have the same electronic configuration. That is meaning they have the same electronic configuration. Neon is 10. Aluminium, when aluminium lose 3 electrons, it becomes 3 plus. You now have what the electron number of electron number of neon, which are what the same electron configuration. If you look at chlorine, chlorine is 17, but when it gain one electron, it become what? 18. So it's not the same thing with what? With neon. Potassium, potassium is 19. When it lose one electron, it become what? 18. So it's not it. This guy, phosphorus is 15. When it gain 3 electrons, it become what? 18. So all these are not isoelectrons to this one here, because also that what? 18, 18, and 18. Just the 18, 18, and 18. They are isolated to what? To argon, which I'm going to look at in what? Second question here. This is that. So the correct option is what? The correct option is what? Is A. Just that. Correct option is what? Is A. Please, if you understand the first one here, leave a comment that you understand. Now, if you need a complete video, leave a comment that you need a complete video so that you can understand this better. How to write elite configuration and quantum number. So let's look at what the next one. Look at what next one. Which of these has the same electric configuration as argon? As argon. Now, sodium. We look at sodium, Na plus. When we look at sodium, only the its neutral atom is what? Is 18 electron. But when it give one electron, we have become what? Negative what? Charge, right? So it's 11, right? The neutral electron, like when it's neutral atom, is 11. But now, when you lose one electron, it becomes 10. So this guy have what? 10. And argon is 18, so this one is not there. It's okay. Now look at what the B. Chlorine. Chlorine is 17, right? Now when it gain one electron, it becomes what? 18. So here is what? Is 18. Is what? Is 18. Now F is 3 plus is what? Is it's transition metal, so we ignore it. This one here is going to be 10 because oxygen is 8. Now when it gains 2 electrons, it becomes 10. So this one is not the answer. This is not the answer. This is not the answer. The only answer is this one here. Two of the have the same electron what configuration. If you write the electron configuration of argon here, argon 18 is what? Is 1s2, 2x2, 2p6, 3s2, 3p6. It's okay. Make it what? 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18. So this is electrical configuration for what? For argon. Chlorine also have 8. Chlorine minus have what? 18. So it's also going to be Cl minus. Now the electron now is now 18. So it will be 1x2, 2x2, 2p6, 3x2, 3p6. They are isoelectric to what? To each other. So when the question is being asked at all, isolating, they have the same electron configuration. So if you don't want to write on here, just know the electron number. Just like here, the electron number here is 10. Here is 18, here is 10. Just so you know that now argon is what? Is 18. For neon, we know that neon, the electron number is 10, right? This one is 10, this one is 18, this one is 18, this one is 18. So this is the correct number. Just like you don't know how to write the electron configuration. Look at what the third question here. So that determine the numbers of unpaired electrons in 1x2, 2x2, 2p6, 3s2, 3p5. Good. Now, after you have written your electron configuration, now there's one thing you need to understand here. There's one thing you need to understand here. You look at what the last one. So if immediately they say unpaired electron, unpaired. Now you ignore the rest. You look at the last one. The last one is 3p5. 3p5. Now remember, we have called the SPDF. So S, P, D, and F. S have only one orbital, right? Only one suborbital. P have 3 suborbital. D have what? 5. 1, 2, 3, 4, 5. Then F have what? 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7. This is that. So now X have 1 suborbital, P have 3 suborbital, D have what? 5 suborbital, and what? F have what? F have what? 7 suborbital. Now when we look at what? 3p5. We have to look at what the P orbital. P what orbital? So going to be P orbital only have what? 3 suborbital. So here we have this one here. 1, 2. Can you see that? How many electrons do I have here? I have 5 electrons. So how do you fill the 5 electrons? How do you fill the 5 electrons? You use Hund's rule. What is Hund's rule? only state that when filling electrons into degenerate orbitals, electrons are filled single forward pairing. What does it mean? When you are filling electrons into this one here, this suborbitals here, they must spin up before spinning down. That is called Hund's rule. Please, if you don't have to write the configuration, I don't know quantum number, please kindly go and check out my complete video. The link will be at the description below. It's going to be of great help to you. So here we have 5 electrons. Just that according to Hund's rule here, you have 1, they must spin up first. 1, 2, and 3, right? So 1 to 3, I've used what 3 out of it. You left what with 2. Then I'll come back again. I now have 1, 2, making what 5. Making the what 5. They're asking how many unpaired electrons. If they ask you how many paired electrons do you have here, we have 2 paired electrons. How many unpaired electrons? Here we have 1 unpaired electron. So the answer that there's supposed to be options here. There's supposed to be options here, but the options are not here. So it's going to be 1 unpaired. The answer is 1. One what unpaired, then 2 paired. Most of them don't ask you how many paired electrons. The paired electrons are 2. Easy. Now, in case you see this kind of question here, just answer it like that. Now, question 4. Write the electronic configuration for oxygen 18. Oxygen 8. So, how do you write the electronic configuration? Now, this is a blueprint of what you will be using. You have for the first 30 elements, because most of the time you'll be seeing the first 30 elements, first 2 or 30 elements, which is 1x, 2x, 2p, 3s, 3p, 4x, 3d. Now you have to take note of this one here. It's okay. So your JAMB won't exceed this. For my research, your JAMB won't exceed it. 1x, 2s, 2p, 3s, 3p, 4x, 3d. Remember, S can accommodate 2 electrons, P can accommodate 6, right? D can accommodate what 10, right? So now you have to start filling it from the lowest to the highest. Now you use what the proton number. The proton number, if you check it on here, is a neutral atom. So in a neutral atom, the proton number is also the same type as the electron number. You are using the electron number. Here's what is a neutral atom. Because a neutral atom, you are using what the electron number, which is going to be what 8. So how do you write it here? The electronic configuration is going to be 08 is what? You take the first one here. Here we have 1x. How many electrons can S can accommodate? 2. You put 2 here. Can you see that? You put 2 here. So out of the 8, I've used 2. Let's what 6. Let's continue. Here we have 2x2. 2x what 2. Can you see that? 2x2, right? So out of the 4 electrons, out of the 8 electrons, I've used 4. Let's what 4, right? Let's move on here. Here we have 2p. Now, P can accommodate electrons, 6 electrons, 6 electrons. So, here I've used 2, and here we have total of 8, which is what 4 is left, because 4 minus 8 is 4. This guy can accommodate 6 here, but you only have 4 electrons left. So, you now have 4. It's okay. Now, in the exam, they must have 2. How many unpaired electrons do you have here? How many unpaired electrons do you have? Just like you have that one there. Right? How many unpaired electrons? Here we have this one here. So go ahead. How many unpaired electrons do you have here? So go ahead, drop it at the comment section. Let me hear from you. How many unpaired electrons do you have? So let's look at question number 5. How many electrons are in the word L share of this? How many electrons are in the L share? Now let me explain to you here. Now, when it comes to quantum number, we have called principal quantum number. Principal quantum number no have the share. S, no, we have the first share, second share, third share, fifth share, sixth share, seventh share, right? And so on and so forth. Now, let me explain something to you, very important. Now, in the study of atom, right, we have what called the nucleus. The nucleus contains the proton and the neutron, right? Then we have the shares surrounding what the nucleus, and electron revolve around it. Now, this is the first share, this is what the second share, this is what the third share, this is what fourth, and so on and so forth. As the share increases, the size of the atom tends to increase, which I'm going to look at in the periodic table, right? So the first share, which is going to be number 1. So that's why if you check very well, you have what called K, L, M, N, O, P, Q in chemistry, right? So you have 1, 2, 3, 4, 5, 6, and 7. It's okay. In chemistry, the first shell is what is K shell, K shell, K shell. The second shell is what is the L shell. The third shell is what N N O P Q. I So now the numbers of electrons that will occupy by each shell differs. The more the higher the shell, the more the electron can accommodate, which I'm going to talk about next time, right? Or you can check out my complete video on quantum number. You understand here. So now, if for example now we have this electron, they say how many electrons are in the L shell? How many electrons in the L shell? The L shell is what is second energy level, second energy level, right? So first of all, we want to write electrical configuration for what? Phosphorus. So let's write electrical configuration for what? Phosphorus. Let's write electrical configuration for what? Phosphorus. Remember, I've given the blueprint of how to write electrical configuration, which is what? 1x, 2x, 2p, 3x, 3p, 4x, 3d, right? So phosphorus, I use what? 15 here. So it will be phosphorus 15. You're going to be take the first one here, which was 1x2, right? 2x2, 2p6. Now, if you check very well, out of 15, we have used 10. How many left? 5, right? So let's continue. Here we have 3x2. We're going to be at 12, right? How many left is 3? How many left is what? Is 3. We're going to be 3p3. 3p what? 3. Right there. So now we have got the K shell. First shell K is equal to what? 1, right? L equals to what? 2. KL M is equal to what? 3, right? So first shell, which is this guy here, it only have 1x. Just and this one is what? The K shell. They only have s orbital and 2 electrons. Just and now this is called the K shell. Now here we have 2 and 2. So that this 2 here is L. It have 2x and 2p, which is what this one is what is L, right? Then we have 3. 3 is what is the M. So you have M. Can you see that? So how many electrons do we have in the K shell? The numbers of electrons we have in the K shell is 2. The numbers of electrons we have in the L shell is what? Is 8. 2 plus 6, which is 8. Do you understand? Why for M, the numbers of electrons which I have is 2 plus 2, which is what? Is 5. They're asking how many electrons are in the L shell, which is what? 2 plus 6 is what? Is 8. So the option is what? Is C, which is what? Option 8. 8. If they ask here how many electrons are in the K shell, is 2. How many electrons in the M shell is what? 6. No, it's 5. Can you see that? So that is why you need to pay close attention to all this thing there. And if you check very well, each of them, here we have 2, we have 2 there. Here we have 5, we have 5 here, and here we have 8, we have 8 there. Just now. So if someone does not really have good understanding of this things here, they will not be able to get the correct answer. That is why I say that chemistry, normally you don't do guessing work in JAMB and expect to score up to 200 or yes, guessing work is not going to work when it comes to chemistry or any exam at all. So that is why you need to take your time to master this topic very well, so I'll be able to answer any question you see. That is why if you are still struggling with math, chemistry, and physics, I will encourage you to join our private online class where I personally take you. Just and we have our private group where we learn every single day. There are some videos that are not available on YouTube. Just and they are only meant for my private students because these are people who pay monthly. Just and so if you really want to learn very well, like you want to master math, chemistry, and physics very well in the shortest time ever possible, then join our private online class. Our private online class is not free. Don't come to my game and say you want free class. I don't do free class. You pay every single month or you pay one-time payment. Do you understand? Now the fee is about the monthly payment. The fee is about 5,000 to 8,000 naira monthly. That range, right? Then the one-time payment is 24,000 to 8,000 naira monthly. So depending on the one you want to go for, right? So we have done with question 1 to question 5. All this is helpful. So now question 6. We have done this one before. You like put question 6 at the comment section. We have done it before. It said if the electronic configuration of an element is 1s2, 2s2, 2p3, how many unpaired electrons do we have here? You go ahead and do this one. Just now, go ahead and do this one for me. Right? Go ahead and do that one. So you do this one for me. Leave it at the comment section. I expect you to be able to do it yourself because this is what we have done. So now question number 7. How many principal electron share are as an atom with electric configuration is this? Principal, let's look at some of the principal electron share. Now here we have, remember, the first one is called K share, the second one is called L share, the third one is what is M share. So they should ask here, how many principal electron share do we have here? It's 3, because here we have K, L, and M. Do you understand? So for this one here, if as we want to answer this question here, for this we have 3 electron share, because we have called the K share, we have called the L share, and we have called the M share, right? K, L, M, because here we have 1x to what 3p, K share, M share, what M, L share, what M share. So yeah, if you check very well, here we have 1x2, 2x2, 2p6, 3x1. So here we have K share, L share, and M. So the option is what is 3. Just so these and these have the same electron share. That is have the same electron share. So look at the last one. Element X has the electric configuration. Here we have this one here: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Its atomic number and the group number in the periodic table will respectively be. So look at something here. If you have been given something like this, please pay close attention here. When you have a question like this, and then I ask you what is the electronic configuration, what is the what is the atomic number? What I want to do here, the word atomic number, right? Atomic mass. Atomic mass. It should not be atomic mass. It should not be atomic mass. No, it should not be atomic mass. It should be atomic number, not atomic mass. It should be atomic number, not atomic mass. A mistake. Probably I made a mistake. Atomic number, right? So what is atomic number here? You look at it. 2 plus 2 plus 6 making it what 10, right? Plus 2 plus making it what 18 plus 2 is 20. So the atomic number is what is 20. Then what is the group? The group is what is 2. So the group number is what is group number is what is 2. Now I've done a complete video on this. I've done a complete video how to use the electric configuration to identify the block, the group, and the period of an element in the periodic table. So without you having the periodic table, you can actually detect them. Do you understand? So we have come to the end of this video here. If this video is helpful, please leave a comment section that this video is helpful. If you have any question, also leave it at the comment section. I hope this video is helpful. So go and check out my complete video on this topic here. I will leave the link to at the description below so I can get it. But I'm going to see some of this question in the exam. If you want to join our private class, send me a DM now so I can be added to the group class. Make a payment and be